Hello there, and welcome to the Sleepy Nature channel. Did you know that the whole natural world, every tree, every ant, every stone, every raindrop, is doing something quietly, thoughtfully, all on its own? Not with big, loud decisions, but with small, soft ones. The kind you might miss if you aren't paying attention. Tonight, we are going to pay attention, slowly, gently, without any hurry at all. We're going to discover the quiet intelligence of nature, the ways it listens, remembers, and finds its way. So come, let your shoulders drop. Let your hands rest wherever they feel comfortable. Breathe in slowly and let the air out like you're fogging a cool window on a winter morning. There's nothing you need to do right now, nowhere to be. Just this, the soft, breathing world waiting to tell you its secrets. Let's begin in a forest, a very old one. The trees here are tall and still, the way trees always seem to know how to be still. The light falls down through the canopy in long, slow columns, like golden thread unwinding from a spool. And beneath your feet, though you might not realize it, there is an entire thinking world just under the soil. The roots of trees are connected to each other through a web of very fine threads called mycelium, the root-like structures of fungi. This network stretches beneath nearly every forest floor on Earth, so quietly and completely that scientists sometimes call it the wood wide web. Through it, trees share water and sugar and minerals, passing what they have to those who need it. A large mother tree, the oldest, tallest one in the forest, will send extra carbon and nutrients through these threads to her seedlings, especially when they are young and cannot yet reach enough sunlight on their own. She doesn't make a sound, she doesn't move, and yet somehow she knows. When a tree is being eaten by insects, it releases chemicals into the air. Not quite a smell you could name, but a kind of signal. The trees nearby receive it. They begin producing more tannins in their own leaves, making themselves less tasty, less inviting, before the insects ever arrive. They prepare, they listen ahead of time. Some trees even change what nutrients they send through the soil, depending on the season. In autumn, they pull nitrogen back into their roots before dropping their leaves, saving it for spring. Nothing is wasted, nothing forgotten. The forest remembers what it needs. Birch trees are particularly generous. They share more sugars through the fungal network than almost any other tree, and they often donate nutrients to neighboring species, even trees of a completely different kind. There is no competition in their quiet giving. They simply offer what they have. If you're enjoying this story, feel free to leave a like. It helps more people find their way to a quiet night's rest. An oak tree can live for 500 years or more, and in that time, its roots may travel as far as 90 meters from its trunk, weaving through the soil like slow, purposeful rivers. Those roots feel the world. They grow toward moisture, away from salt, around rocks, beside other roots, always adjusting, always finding the softer way forward. When a tree's bark is damaged, it begins producing a resin, a thick amber liquid that seals the wound, traps bacteria, and prevents infection. Some trees are so good at this that their resin has been found in ancient archaeological sites, used by people thousands of years ago as a kind of natural medicine. The tree had already figured it out. the willow tree releases a chemical into the soil around it that slows the growth of other plants nearby. Not in a cruel way, but in the same gentle, inevitable way a shadow does. It simply takes the space it needs, and other plants, sensing this, grow in a different direction. No argument, just understanding. Inside a beech tree, the wood grows in a pattern of rings, one ring for each year of its life. In years with plenty of rain, the ring is wide and pale. In drought years, it is narrow and dark. If you hold a slice of a very old beech in your hands, you're holding its whole life, its memory, written in wood. There is a grove of aspen trees in Utah, in the United States, called Pando. What looks like thousands of separate trees is actually one single organism connected by one enormous root system underground. It is considered one of the oldest and heaviest living things on Earth, perhaps 80,000 years old. One quiet, breathing being spread across 43 hectares of forest. A seed knows when to wake up. It waits in the soil, sometimes for years, until the light and moisture and temperature are exactly right. Some seeds need to pass through the digestive system of a bird before they will germinate. Others need to feel the heat of a wildfire. Each one holds its own quiet instructions, waiting for the right moment to begin. Pine trees in cold climates produce a kind of natural antifreeze in their cells as autumn deepens. The same way, some animals change their blood chemistry before winter. The tree senses the shortening days long before the cold arrives and begins to prepare. It doesn't need to be told. It simply knows, the way the body knows to breathe without being reminded. Notice how easy your breath is becoming, in and out. The forest around you is doing the same, exhaling oxygen, inhaling carbon dioxide, breathing in its own slow way, as it always has, as it always will. The forest is still around you. That great, patient breathing continues beneath everything, in the soil, along the roots, through the canopy above. And now, very quietly, something is moving at the edge of the trees. Something small, an ant, just one at first, then another. Then, before long, a thin ribbon of them, walking in a line so precise it looks as if someone has drawn it with a very fine pencil. Ants have no central brain, no leader who issues orders, no one in charge, and yet they build cities, farm food, and solve problems that would challenge a computer. When an ant finds food, it carries a tiny amount back to the nest, while leaving behind a trail of pheromone, a chemical scent that says, in ant language, "Come this way." Other ants follow the trail. The more ants use it, the stronger it becomes. The shortest, most efficient path always gets the most traffic, and so the colony naturally finds the best route without anyone planning it. Leaf cutter ants carry pieces of leaf much larger than themselves through the forest, sometimes for hundreds of meters, back to their underground gardens. But they aren't eating the leaves. They are feeding them to a fungus that they grow in special chambers deep beneath the earth. The ants farm this fungus, which they have been cultivating without interruption for 50 million years. Their relationship with that particular fungus is so close that the fungus exists nowhere else in nature. When a leaf cutter ant discovers that a plant is toxic, it stops cutting it and communicates this to the rest of the foraging workers. The information spreads through the colony in a matter of hours, and the entire group redirects to a different plant. No memo, no meeting, just the quiet ripple of shared knowledge. Army ants, which live in the rainforest, have no permanent home. They move as a living wave across the forest floor, and when they need to cross a gap, a crack in a log, a space between roots, they build a bridge out of their own bodies. They lock their legs together, hold still, and let the rest of the colony walk over them. Then, when everyone has crossed, the bridge dismantles itself and moves on. Quiet, temporary, perfect. Our playlist has many more stories just like this one. Soft nights full of wondering. You might like to check it out before you sleep. Some ants tend to aphids the way farmers tend to cattle. They protect the aphids from predators, shelter them from rain, and even carry them to the best feeding spots on plants. In return, the aphids produce a sweet liquid called honeydew, which the ants drink. This arrangement has been going on for millions of years. Both creatures, in their small, quiet way, have learned to rely on each other. Underground, an ant nest is an extraordinary structure, with separate rooms for different purposes. Nurseries for eggs, storerooms for food, ventilation shafts that draw cool air in from below and let warm air rise out through the top. The temperature inside can stay remarkably stable even when the outside world swings between extremes. The ants build all of this without blueprints, without measurements, without ever standing back to look at the whole. A single ant weighs less than a milligram, and yet, together, all the ants on Earth weigh roughly as much as all the humans on Earth. They are everywhere, in the soil of every continent except Antarctica, quietly aerating the Earth, breaking down dead matter, redistributing seeds, making the ground breathe. Weaver ants build their nests by stitching leaves together using silk produced by their own larvae. An adult ant will hold a larva gently in its jaws and move it back and forth between two leaf edges, like a needle threading through cloth. The larva, for its part, produces silk calmly and continuously. Together, they make something none of them could make alone. Fire ants, when floods come, do something remarkable. They link together, thousands of them, into a living raft that floats on the surface of the water. They take turns being the bottom layer, the part that gets wet. No ant drowns. The raft can last for weeks, bobbing gently on the floodwaters, waiting for dry land to arrive. And all of this happens through nothing more than touch, chemistry, and some ancient, wordless understanding. Now, somewhere above the ants, a bee is hovering near a flower, and the intelligence the bee carries inside its small, humming body is extraordinary in its own right. A honeybee brain contains roughly 1 million neurons, about 100,000 times fewer than a human brain. And yet, a bee can navigate using the sun, remember which flowers she visited this morning, and even communicate the location of a food source through dance. The waggle dance is one of the most precise communication systems in the animal world. A bee returning to the hive will perform a figure 8 on the comb, waggling her abdomen during the straight part. The angle of that straight run, relative to vertical, encodes the direction of the flower from the sun. The duration of the waggle encodes the distance. Other bees watch, feel the vibrations through their feet, and fly out directly to the flower, often hundreds of meters away. Bees also vote. When a colony needs a new home, scout bees go out and search for suitable cavities. Each returning scout performs a dance whose enthusiasm reflects how good she thinks her find is. Other scouts go to visit the best sites, then return and dance their own opinions. Over hours and days, through this gentle democratic buzz, the colony gradually agrees on the best location, without any bee having seen all the options. A honeybee can recognize human faces. In a study, bees were shown photographs of human faces alongside a sugar reward for one specific face. They quickly learned to choose that face reliably, even from new angles. They are doing this not because they recognize people, but because they have evolved to remember complex patterns in nature. The faces of flowers, the patterns in petals that guide them toward nectar. We just happen to look a little like very unusual flowers. Let your body sink a little further into wherever you are resting. Feel how the world carries you, without effort, without asking. The ant and the bee do not worry about what tomorrow will bring. They simply do the next small important thing, and in that perhaps they are wiser than we know. You are drifting now, the way a leaf drifts on a still pond, not going anywhere, just resting in the gentle current. And all around you, the evening air is soft and faintly cool, the way air always becomes just after the sun begins its slow descent. This is the hour when the birds begin to settle, when the colors in the sky go warm and low, when everything in nature seems to exhale at once. Birds know things we are only beginning to understand. The Arctic tern flies from one pole to the other every single year, from the Arctic summer to the Antarctic summer, and back again, covering up to 70,000 kilometers in a single journey. It does this for decades. It has no map, no compass that we can see, and yet it navigates with extraordinary precision, using the sun, the stars, the Earth's magnetic field, and perhaps even the smell of the ocean. The longest migration of any creature, a whole life spent moving between light and light. Many migratory birds have tiny crystals of magnetite in their beaks, the same mineral used in compass needles, which may allow them to feel the Earth's magnetic field the way you feel the warmth of sunlight on your skin. Some scientists believe they may even see magnetic fields as a faint glow overlaid on their normal vision, guiding them forward through the dark. The bar-tailed godwit holds the record for the longest non-stop flight of any bird, 11 days, over 11,000 kilometers, from Alaska to New Zealand, crossing the Pacific Ocean without once landing on water or resting on land. Before the journey, it eats so much that its body weight nearly doubles. Then, in a remarkable act of preparation, it shrinks some of its own organs, its digestive system, its liver, to make room for the extra fuel. It dismantles parts of itself and then rebuilds them on the other side. If this is the kind of story that helps you rest, a like and a comment mean more than you know. They help this quiet little channel reach more sleepy people. Crows remember faces. If a crow has had a bad experience with a particular human, being captured and tagged by researchers, for example, it will not only avoid that specific person for years, but will warn other crows about them. The alarm call a crow makes for a dangerous human can spread through a local crow population, so that birds who have never met that person will begin to scold and avoid them, too. The knowledge travels. Clark's nutcracker, a bird that lives in mountainous forests in North America, buries up to 30,000 pine seeds each autumn in thousands of separate caches spread across several square kilometers of terrain. Over the following winter and spring, it retrieves most of them, using spatial memory so precise it astonishes researchers. It remembers not just where the seeds are, but which caches it has already emptied, and which ones had the most seeds to begin with. The lyrebird of Australia is one of the most gifted mimics in the natural world. It can reproduce the calls of over 20 other bird species with near-perfect accuracy. But beyond birdsong, it has been recorded imitating chainsaws, camera shutters, car alarms, and even human voices, sounds from its environment folded into its song, which it performs each dawn in its clearing in the forest, a mosaic of everything it has ever heard. Starlings murmurate. On autumn evenings, thousands, sometimes millions, of them move together through the sky in a single, fluid shape that bends and billows like smoke in slow motion. Each bird follows only the 7 nearest birds to it, adjusting its speed and direction accordingly. There is no leader. The whole flock thinks as one, a liquid, rolling intelligence that stretches across the sky, and then, all at once, folds into a roost and goes quiet. Pigeons navigate home, using a combination of the sun, the Earth's magnetic field, and infrasound, very low-frequency sound waves, far below what humans can hear, that bounce off mountains, coastlines, and other large landscape features. Pigeons hear the shape of the world and use it as a map. They feel the land in the sound of the air. New Caledonian crows are among the very few non-human animals known to make and use tools. They fashion hooks from twigs and leaves to extract insects from crevices, not by accident, but deliberately, shaping the tool to the task. In laboratory experiments, they have solved multi-step puzzles involving several tools in sequence, understanding that one tool must be used to obtain another before the final goal can be reached. The great tit learned in the mid-20th century to open foil-topped milk bottles left on English doorsteps, piercing the cap to drink the cream. Within years, this skill had spread across the country, from population to population, in a wave of cultural learning. Birds watched other birds, copied them, and passed the knowledge on. A new tradition, invented and shared without a word. Some birds actually teach their young to sing. In species where the song is complex, white-crowned sparrows, for example, the young bird must hear the correct song during a specific sensitive period in its first weeks of life. If it doesn't hear it, the song will be imperfect or incomplete. But given the right teacher at the right time, the fledgling will eventually reproduce the song exactly as it was learned, adding its own subtle variations, just as we might put our own softness or strength into a story we were told as children and now tell ourselves. The wood thrush sings with 2 voices at once. Deep inside its syrinx, the avian equivalent of a voice box, it has 2 separate sound-producing membranes that can vibrate independently, allowing it to harmonize with itself. In the long violet dusk of a summer evening, the wood thrush's song rises and falls and braids around itself like water over smooth stone. You can hear in it something that feels like memory, though you can't quite say of what. Breathe in with the birds now, slowly, easily, and as you breathe out, let your body feel a little heavier, a little warmer, a little closer to sleep. The starlings are folding into their roost. The thrush has sung its last note. The sky above the trees is turning the color of old roses, and everything is becoming quiet again. The night has almost arrived. The sky has deepened to a soft, dark blue, the color of still deep water, and one by one, the the stars are arriving. You can feel the temperature settling, the air growing just a little heavier, a little slower, the way everything in nature finds its natural pace when it is no longer rushing toward or away from anything. Let's go down now, down toward the water, to a stream moving gently through the darkening forest, its surface catching the last of the light in small, moving pieces. Water has a kind of intelligence all its own. A river always finds the sea. No matter how many hills are in its way, no matter how many times it bends and loops and turns back on itself, a river eventually arrives where it is going. It does this by following the simplest law. It always moves toward lower ground. One small rule, followed with absolute patience, and the result is a journey from the mountains to the ocean, sometimes thousands of kilometers long. Rain falling in a forest is slowed and softened at every stage. First, by the canopy, which intercepts a large portion of it before it reaches the ground. Then, by the moss and leaf litter, which absorb it like a sponge. Then, by the roots, which drink deep and hold the rest. A healthy forest releases water slowly through streams and springs. For months after the last rain has fallen, the forest is a kind of memory for water, holding it gently, giving it back slowly. Trees near rivers literally pull water upward from the roots to the leaves through a process that requires no pump and no energy input from the tree itself. Water molecules cling to each other, cohesion, and cling to the walls of the tiny tubes inside the tree, adhesion. As water evaporates from the leaves, it pulls the water below it upward, like a chain. In a tall tree, this chain of water stretches 30 or 40 meters from root to leaf, lifting countless liters every single day. There are more stories in the playlist, whole nights of quiet facts and soft worlds. Do have a look when you feel ready. A raindrop that falls into the ocean today may once have been inside a dinosaur. Water molecules cycle through the atmosphere, the soil, the oceans, and living creatures in an endless loop. The water you drink carries within it pieces of the oldest rivers, ancient glaciers, deep ocean trenches, and the cells of every creature that ever lived. Water remembers everything, not in any way we can read, but in its endless, patient movement. Rivers shape themselves. Where the water moves fastest, it erodes the outer bank of a bend. Where it slows, it deposits sediment on the inner bank. This makes the bend gradually tighter and tighter until, one flood season, the river cuts across the curve entirely and abandons the old bend, leaving behind a crescent-shaped lake called an oxbow. The river changed its own course. It edited itself. Mangrove forests grow at the edge of the sea, where the water is salty and the ground is unstable, conditions that would kill most trees. They have evolved extraordinary root systems that arch above the mud like fingers reaching into the air, absorbing oxygen directly from the atmosphere, while their lower roots anchor in the anaerobic mud below. They breathe through their feet. They hold coastlines together with quiet, steady hands. The water in a glacial lake is often a stunning, impossible blue-green, the color of frozen light. This comes from rock flour, tiny particles ground by the glacier from the stone beneath it, so fine they stay suspended in the water and scatter light in that particular dreamlike way. The color of a glacial lake is the color of the mountain remembering the glacier. Kelp forests grow along cold ocean coasts, their long fronds rising 30 meters or more from the seafloor toward the surface light. Inside them, hundreds of species find shelter, food, and nursery grounds. A kelp forest can grow half a meter in a single day under the right conditions, one of the fastest growing structures in the natural world. And when it dies back, it sinks to the ocean floor, carrying with it enormous amounts of carbon absorbed from the atmosphere during its life. The sea takes what the sea gave and holds it deep. Otters hold hands while they sleep, so they don't drift apart in the current. A group of otters resting on the water's surface will sometimes link paws into a loose, floating raft, their round faces calm, their whiskers still. They call this a raft of otters. In the silver light of an early morning, all those linked hands on the water, it looks like the world's most peaceful thing. Water can exist in 3 states: solid, liquid, gas. And on Earth, all 3 are present simultaneously at every moment. Ice in the mountains and poles, liquid in rivers and oceans and the blood of every living creature, water vapor rising invisibly from every warm surface. There is nowhere on this planet where water is not present in some form. It is always here, always moving, always becoming something else. In the deep ocean far below the light, there are hot vents in the seafloor that release warm, mineral-rich water into the cold darkness. Around these vents, entirely without sunlight, entire ecosystems thrive. Tube worms 2 meters long, pale crabs, ghostly fish. Life found a way here not through light, but through chemistry and heat, through the deep, slow breath of the ocean floor. Intelligence, again, in its quietest form. Feel the water around you, not literally, but in that soft, full sensation of being supported, like the water that holds the otter's linked hands. Like the rain, the forest drinks slowly, slowly. You are held. You are supported. You don't need to do anything but rest. The river has found its way to a meadow now, somewhere wide and open, where the grasses grow tall and the night is full of small movements, the rustle of a moth, the slow opening of a night-blooming flower, the almost imperceptible turning of leaves toward a break in the clouds. The meadow breathes at its own pace, and everything in it is doing something quiet and purposeful, though you might never notice unless you were very still. Grass is one of the most successful plants on Earth. It covers more than 1/4 of the planet's land surface. Prairies, savannas, meadows, steppes, and it has been doing so for tens of millions of years. The secret of its success is partly in how it grows. Unlike a tree, which grows at the tips of its branches, grass grows from the base. This means that grazing and trampling and cutting don't stop it. It simply continues growing from the bottom, as calm and persistent as the tide. A single grass plant can have roots that go deeper than its blades are tall. Prairie grasses in particular develop root systems that extend 2, 3, sometimes 5 meters into the earth. These roots hold the soil together against wind and water, and when the plant dies, they leave behind channels that allow air and moisture to pass deeply into the ground. A healthy meadow is as much underground as above it. Wildflowers time their blooming so that different species flower at different points through the season, ensuring that pollinators always have something available from early spring to late autumn. This is not an accident or a coincidence. Over millions of years, Flowers and their pollinators evolved together, each adapting to the other, so that the meadow as a whole provides an unbroken chain of food. The meadow is thinking ahead. If this story is helping you drift towards sleep, a gentle comment below would make the channel very happy. It helps keep these quiet evenings going. The foxglove is toxic to the human heart in large doses, but at very precise, very small doses. A compound from its leaves, digitalis, has been used for centuries to regulate irregular heartbeats. The plant knows something about the heart that we took a very long time to understand. Many of our medicines began as observations of what plants did quietly, on their own, for millions of years. Sunflowers are not one flower, they are hundreds. What looks like a single bloom is actually a dense circle of tiny individual flowers called florets, arranged in a spiral pattern. The pattern follows the Fibonacci sequence, the same series of numbers found in pine cones, nautilus shells, and the spirals of galaxies. The sunflower arrived at this arrangement because it allows the most florets to fit in the available space with the least wasted room. It found the mathematical answer without mathematics. Clover enriches the soil it grows in. Its roots host bacteria that take nitrogen from the air and fix it into the soil in a form that other plants can use. Farmers have known this for centuries and plant clover in rotation with other crops, letting the earth recover and grow rich again between harvests. The clover is doing this work without being asked, simply as part of how it lives, quietly improving the world around it. The dandelion is among the most intelligent survival strategists in the plant kingdom. Its seeds float on perfect little parachutes. Its root can regenerate a new plant from even a tiny fragment left in the soil. Its leaves emerge in a rosette that lies flat against the ground, where no mower can reach it. It blooms in almost any conditions, in any soil, at any time of year. It has been called a weed, but what it is really is very, very good at living. Moss can survive complete desiccation, losing up to 98% of its water content, and then return fully to life when moisture arrives again. Some mosses have been revived after being frozen for centuries in glaciers. They don't die in the dry. They simply wait, their cells in a state of suspended quiet, holding the memory of being alive until the conditions return. Then they green again, as if no time has passed at all. Night-blooming flowers, jasmine, moonflowers, evening primrose, open at dusk and release their fragrance into the cooling air, where it carries further than it would in the heat of the day. They are visited by moths and bats rather than bees, and their petals are often white or pale yellow, luminous in low light, designed to be seen not by the sun but by moonlight. They have arranged their whole lives around the night. The mimosa plant, if you touch it, closes its leaves. They fold together gently, like small hands brought to rest, and then, after a few minutes, they open again. But here is the remarkable thing. If you keep touching it in the same way, it learns not to bother. It recognizes that the repeated touch is not a threat and stops responding to it. The mimosa remembers, a plant with no neurons, no brain, no anything we might call a mind. And yet, it learns. Rainforests are the lungs of the earth, and they also make their own rain. Water vapor released by the trees rises and cools into clouds above the canopy, then falls back as rain. In the Amazon, Up to half of all rainfall is water that has already cycled through the forest at least once. The rainforest is talking to the sky. The sky is listening. It sends the water back. The meadow is quiet now. A moth moves through the darkness with the unhurried certainty of something that has always known where it is going. The grasses sway once, settle. A fox pauses at the field's edge and listens, ears forward, nose reading the air, then moves on, soft-footed, into the dark between the trees. Everything is intelligent here. Everything knows its place. And your place, right now, is here, warm and still, drifting on the surface of the night, like the otter's linked hands on the river. Let's go somewhere higher now. Not a climb, but a floating, the way your breath carries you upward if you let it. Imagine rising above the meadow, above the river, above the treetops, until you can see the whole landscape below you, pale and silver in the moonlight. Mountains in the distance, their slow, enormous shapes like sleeping animals, covered in stone and snow and silence. Mountains are among the slowest thinking things on earth and among the most certain. The Himalayas are still rising. The Indian subcontinent is moving northward at roughly 5 centimeters per year, the same speed a human fingernail grows. And where it meets the Eurasian plate, the crust buckles and rises slowly, continuously. Over tens of millions of years, this patient collision has built the highest mountain range on Earth. Patience, enormous patience, is one of nature's most powerful tools. Granite forms deep underground, where magma cools so slowly over millions of years that its crystals have time to grow large. The texture you see in a polished granite countertop, that scattered pattern of interlocking crystals, is the record of an extraordinary patience. Each crystal took longer to form than most species have existed on Earth. The rock remembers that time in its grain. Stones in riverbeds are rounded not by a single great force, but by countless small ones. Billions of gentle collisions with other stones, with the riverbed, with the current itself. Each collision removes a little roughness. The stone becomes, over decades and centuries, perfectly smooth, perfectly egg-shaped, perfectly at peace. Softness made smooth by softness. The full playlist on this channel has many more soft evenings in it, perhaps worth exploring on another quiet night. The mountains have their own weather. As moist air from the lowlands rises up a mountain slope, it cools, and its moisture condenses into cloud and rain. The windward side of a mountain can receive many times more rainfall than the leeward side, the side sheltered from the wind, which may be near desert. A mountain is not just a shape. It is a weather-making machine, a rain catcher, a cloud builder, simply by being tall and still. Glaciers move. They flow, almost imperceptibly, like frozen rivers, downhill under their own enormous weight. The ice at the bottom deforms under the pressure, and the whole glacier inches forward. As it moves, it carries stones and boulders scraped from the bedrock, and when it finally melts, it deposits them in new places, sometimes thousands of kilometers from where they began. The glacier is the Earth's slow postman, delivering stones across ages. Caves form when slightly acidic rainwater, acidified by carbon dioxide absorbed on its way through the soil, dissolves limestone over thousands of years. A cave is literally a hole made by rain and time and carbon dioxide. And inside that cave, the same process runs in reverse. Water dripping from the ceiling deposits dissolved minerals one drop at a time, building stalactites and stalagmites over centuries. A cave grows its decorations at the pace of breathing. The world's deepest lake, Lake Baikal in Siberia, is nearly 2 kilometers deep and holds approximately 20% of all the fresh water on the surface of the earth. It is so old, 25 million years, that it has evolved unique species found nowhere else. The Baikal seal, for example, which lives entirely in fresh water, far from any ocean. The lake is so deep and so cold that it has become its own world, separate and complete. Volcanoes are how the planet breathes. Deep in the mantle, rock melts under enormous heat and pressure, and when it finds a weakness in the crust, a crack, a thin spot, it rises. A volcanic eruption is the earth exhaling, releasing heat, gas, and fresh rock from its interior. The new rock cools and becomes new land. Hawaiian islands were built this way, island by island, eruption by eruption, out of nothing but ocean and fire and time. The sand on a beach was once a mountain. Rain and frost broke the rock into boulders. Rivers broke the boulders into stones. Stones broke into gravel. Gravel broke into sand. And the sand was carried to the sea, where the waves arranged it into the soft, pale shore, where you might one day walk barefoot in the early morning. The mountain did not disappear. It became something softer. Wind carries seeds, pollen, fungal spores, and even entire living insects across continents and oceans. The trade winds carry dust from the Sahara across the Atlantic, where it falls into the Amazon, fertilizing those ancient, nutrient-hungry soils with minerals from thousands of kilometers away. The desert and the rainforest, on opposite sides of an ocean, are feeding each other. They have been doing so for millions of years. Snow is silent for a reason. Each snowflake is a lattice of ice crystals with large spaces of air between them. And when snow covers the ground, those countless air pockets trap sound, preventing it from bouncing off the surface. A snowy landscape is acoustically deadened, quieter than almost anything else in the natural world. Snow offers silence as a gift. The stone beneath you, if you could press your hand flat against the oldest stone on Earth, would be nearly 4 billion years old. It has been warm in deep seas, cold in glaciers, lifted into mountains, buried again, and here again. The stone has been everywhere. It doesn't hurry. It has already seen everything there is to see. It rests, perfectly still, in the patient certainty of something that knows it will outlast whatever comes next. Let that stillness settle into you. The stone's patience, the mountain's quiet. Your body, for this small hour, as still as a pebble in a stream, round and smooth and resting in the current, perfectly at home. From the height of the mountains, you can see everything below. The dark sweep of the forest, the silver threads of rivers, the pale meadow. And above, where the sky is completely clear now, the stars. There are more stars in the observable universe than grains of sand on every beach and desert on Earth. That number is almost impossible to hold in the mind, so let it go. And instead, just feel it. The vastness above you, the extraordinary patience of that light, traveling for years and centuries and millennia to arrive at your eye in this particular moment. The light you see from the night sky is old. The nearest star, Proxima Centauri, is about 4 light years away, meaning the light leaving it right now will not reach Earth for 4 years. the stars of the Andromeda galaxy, are 2.5 million light-years away. When you look at it with the naked eye on a clear night, you are seeing light that left before Homo sapiens existed. The sky is a window into the past. Stars are where the elements come from. Hydrogen and helium formed in the Big Bang. Every other element, carbon, oxygen, iron, calcium, was forged inside the cores of stars through nuclear fusion over millions and billions of years. When a large star reaches the end of its life and explodes as a supernova, it scatters those elements across space. They eventually gather into new stars, new planets, new oceans, new life. You are made of stardust, not as a metaphor, but as a simple, literal fact of chemistry. If these quiet nights have been good company, A-like helps the channel very much. And there are more stories waiting in the playlist. The moon's gravity pulls on the Earth's oceans, and the daily rise and fall of the tides is the result of that pull. But the moon is also slowly moving away from Earth, about 3.5 centimeters further away each year. When the moon formed some 4.5 billion years ago, it was much closer, and the tides it raised were enormous. Over time, gravity has found a balance, and the moon withdraws at the pace of a growing fingernail, steady and slow. The moon and the Earth are having a very long, very patient conversation. The northern lights, the aurora borealis, occur when charged particles from the sun stream down along Earth's magnetic field lines and collide with molecules in the upper atmosphere, making them glow. The green you usually see is oxygen glowing at lower altitudes. The rare red is oxygen at higher altitudes. The blue and purple are nitrogen. The aurora is the atmosphere singing in light, responding to the touch of the sun from 93 million miles away. Coral reefs, visible from space, are built by tiny animals called polyps, each one smaller than a pea. Each polyp secretes a tiny limestone cup around its soft body. Over years and decades and centuries, generation after generation, the cups build up slowly into the vast, complex structures of a reef. The Great Barrier Reef is 2,000 kilometers long and has been building for roughly 20,000 years. It was made by patience and repetition and an almost unimaginable number of small, soft bodies doing one simple, steady thing. Bioluminescent plankton make the ocean glow. When disturbed by a wave, a passing fish, a swimmer's hand, some species of dinoflagellate emit a brief flash of blue light. A wave breaking at night on a bioluminescent beach leaves a trail of cold fire in its wake. The light comes from a chemical reaction inside the cell, triggered by mechanical disturbance. The sea is flashing at you. It is saying, "I see you. I am here." The Earth's magnetic field is generated by the movement of liquid iron in the planet's outer core, thousands of kilometers below the surface. It extends far out into space, shielding us from the solar wind, the constant stream of charged particles the sun emits. Without the magnetic field, the solar wind would gradually strip away the atmosphere. The field is invisible, unfelt, unmeasured except by instruments and the instincts of migrating animals. It has been quietly protecting life for at least 4 billion years. Some animals can see ultraviolet light: bees, birds, butterflies, fish. In ultraviolet, a flower looks completely different. It may have bold patterns, landing strips, arrows toward the nectar that are entirely invisible to human eyes. A meadow that looks simple and monochrome to us is, to a butterfly, an intricate, luminous map. We are seeing only one layer of a world with many layers. Fireflies communicate with light. Each species has its own pattern, the number of flashes, the length of each flash, the interval between them. A male flashing his species-specific pattern, a female responding from the grass below. Conversation in light, in the warm summer dark, going on all around you. The field is full of quiet conversations you could not read until you knew the code. There are stars so large that if you put one where our sun is, it would swallow not just Earth, but Jupiter and Saturn too. And there are neutron stars, the collapsed remnants of massive suns, so dense that a teaspoon of their material would weigh billions of tons. The universe holds both enormous and tiny extremes with equal ease. It does not find either one more or less remarkable than the other. In the grand story of the universe, the Earth is 4.5 billion years old, about a third of the age of the universe. Life has existed here for roughly 3.5 billion years. For most of that time, it was single-celled. Complex animals have existed for less than 600 million years. Humans, in our current form, for perhaps 300,000. We are very, very new here, and the stars above us are old, beyond any reckoning, burning patiently through the night, as they were burning long before we arrived, and will burn long after. Look up if your eyes are still open, or close them and imagine the stars, that soft, scattered field of ancient light above you. You are lying on the surface of a planet, in the arm of a galaxy, in a universe older than imagination. And you are here, warm, breathing, safe. That is an extraordinary thing. Come back down now, softly, like the first autumn leaf releasing from its branch. Slowly back through the cool starlit air, back through the treetops, back to the earth. The forest is very dark at this hour, but there is no fear in this darkness. It is the ordinary, familiar dark of a world that has been getting dark every night since the beginning, and finding its way through to morning every time. In the dark, other senses take over, and nature has arranged itself so that even in the absence of light, the world continues its deep, careful intelligence. Bats navigate in total darkness using echolocation, emitting ultrasonic clicks and listening to the echoes bouncing back from surfaces. A bat can detect an object no thicker than a human hair at full flight speed. Its brain processes the time delay, frequency shift, and intensity of returning echoes to build a three-dimensional image of the world around it. Not a visual image, but a sound picture, perhaps as detailed and rich as what we see. The bat is reading the world in sound. Owls have asymmetrical ears, one slightly higher on the skull than the other. This means that a sound reaches the two ears at slightly different times and from slightly different angles, allowing the owl to pinpoint its source in 3 dimensions. In complete darkness, a barn owl can catch a mouse hidden under a thin layer of snow, guided only by the faint sound of its heartbeat and breathing. The owl hears location the way we see it. Moths navigate by moonlight, using the moon as a fixed reference point, keeping it at a constant angle to their bodies as they fly. This works perfectly with a real moon, which is so far away that it stays in one direction as the moth moves. But a candle flame or a light bulb is not far away. As the moth circles it, the angle keeps changing. To maintain a constant angle to a nearby light source, the moth spirals inward. It is not drawn to the light. It is confused by a world it was not designed for. There are many more stories in the playlist, each one a quiet evening with a different corner of the natural world. Come back anytime the night feels long. The eyes of deep-sea fish can be enormous, disproportionately large, because they need to gather every available photon of light in an environment where almost none exists. Some deep-sea fish have eyes pointing upward, designed to catch the faint silhouettes of prey above them against the distant surface glow. Their eyes are like the largest telescopes we built for maximum light gathering in extreme darkness. The platypus has a bill covered in electroreceptors, about 40,000 of them, that detect the tiny electrical fields generated by the muscle contractions of prey animals in the water. It hunts with its eyes, ears, and nose closed, finding everything it needs through the electric whispers of the river. It is feeling a layer of the world that we cannot access at all without instruments. Dolphins sleep with one eye open, literally. One hemisphere of the dolphin brain sleeps, while the other remains awake, keeping the animal aware of its surroundings, surfacing to breathe, and watching for danger. After several hours, the hemispheres switch. The dolphin rests without ever fully going under. Half a brain dreams while the other half minds the world. Salmon return to the exact stream where they were born to spawn, sometimes thousands of kilometers from the ocean, up waterfalls and rapids, through obstacles that seem impossible. They find their home river using the Earth's magnetic field as a large-scale compass, and then, when they are close, using the smell of the specific water chemistry of their home stream. The river smells like home to a salmon. It has always remembered that smell, carried it across years and oceans, and followed it back. The electric eel is not actually an eel, but a relative of the carp, and it can generate pulses of electricity, powerful enough to stun large animals. It uses lower voltage pulses constantly to navigate and communicate, a kind of constant electromagnetic conversation with its environment. It reads the world through electricity, speaks to other electric eels and pulses, and hunts through a field of its own making. A dog's nose contains roughly 300 million olfactory receptors, compared to 6 million in a human nose. The part of a dog's brain dedicated to analyzing smell is, proportionally, 40 times larger than the equivalent region in a human brain. A dog can detect the scent of a single teaspoon of sugar dissolved in 1 million liters of water. They smell time as well as place. They can tell from a scent trail which direction a person was walking, simply from the difference in concentration between the footprints, growing fainter in the direction of travel. Elephants communicate partly through infrasound, very low-frequency sounds that travel through the ground as well as through the air. They receive these signals partly through their feet and the sensitive skin of their trunks, feeling vibrations that carry for kilometers through the earth. An elephant, pressing the sensitive pads of its feet against the ground, is listening to the world beneath it, to the rumbles of other herds, the warnings of approaching danger, the calls of family members far beyond what the eye can see. Trees communicate with each other chemically, electrically, and through their root networks. But some scientists also believe They may respond to sound. Studies have suggested that the roots of young plants grow toward the frequency of running water, not the actual moisture, but the sound of it. If this is so, trees are listening, slowly, quietly, with their whole long bodies. They are leaning toward what they hear. The world in the dark is not empty. It is full of another kind of knowing, soft, precise, ancient. As you drift now toward your own darkness, toward sleep, let your senses relax one by one. You don't need to see anything. You don't need to hear anything. You can simply be here, like a stone in the river, like moss in the cold, like a salmon near home, sensing the water's familiar smell, knowing without needing to think about it that this is the right place to rest. Deeper into the night. Your body is warm. Your breath has found its own slow rhythm now, the way a river finds its pace. No longer hurried by the rain that made it, just moving in its own quiet way toward wherever it is going. Let's spend some time with one of the world's smallest and most extraordinary intelligences, the mushroom, or rather, the organism that makes the mushroom, the fungus. Fungi are neither plant nor animal. They are their own kingdom of life, as different from plants as plants are from animals. There are estimated to be at least 2 million species of fungi on Earth, and we have formally identified fewer than 10% of them. The great majority of life in the fungal kingdom has not yet been described, named, or understood. It is out there, quietly doing what it does, in the soil and the logs and the roots of trees, uncatalogued and unseen. When a spore lands in the right place, it sends out tiny threads, hyphae, that grow outward in all directions, seeking nutrients, connecting with other hyphae, eventually weaving into a mat called mycelium. The mycelium spreads through soil and wood and leaf litter, digesting whatever it finds, absorbing what it needs, and passing the rest along its network. It grows toward food. It retreats from toxins. It merges with compatible strands and avoids incompatible ones. It makes decisions, or something so close to decisions that the difference barely matters. Slime molds are not fungi, but they share some of their strange intelligence. A slime mold is a single cell, one cell, that can grow to 1 meter in diameter and move slowly across a surface, extending pseudopods toward food sources and retracting them from dead ends. In laboratory experiments, slime molds placed on a map of Tokyo, with food placed at the locations of major cities, grew a network connecting those food sources that closely replicated the existing Tokyo rail system. The single cell had solved, through exploration and trial, a problem that human engineers took decades to design. If this has been a soothing evening, a kind comment below would be a lovely thing to leave behind. And the playlist waits for you on another quiet evening. The honey mushroom in Oregon is one of the largest individual organisms on Earth. The visible mushrooms above ground are just the fruiting bodies, the reproductive structures, of a single mycelial organism that spreads beneath several square kilometers of forest. It is estimated to be between 2,000 and 8,000 years old. It exists almost entirely underground, in the dark, doing its slow, essential work. Fungi are the world's great recyclers. Without them, every forest floor would be meters deep in undecomposed leaves, wood, and animal matter. Fungi secrete enzymes that break down lignin and cellulose, the tough materials that make wood hard, into simpler compounds that other organisms can use. Every fallen log in a forest is being slowly, thoroughly disassembled by fungi. The death of a tree is the beginning of a long process that feeds perhaps 100 other species and returns everything to the soil. Penicillin was discovered when Alexander Fleming noticed that a fungus growing accidentally on a petri dish was killing the bacteria around it. The fungus, Penicillium, had evolved the ability to produce this antibiotic as a defense against bacteria that would compete with it for food. It had been doing this, alone and unobserved, for millions of years before a tired scientist happened to look at an accidentally contaminated dish and change medicine forever. Some fungi glow in the dark. Bioluminescent mushrooms emit a soft green light from their caps and gills through a chemical reaction glowing through the night on the floors of tropical forests. The light may attract insects that carry and disperse the mushroom spores. The mushroom is using light as a language, speaking to the dark with a glow that carries its reproductive message. In the jungle, in the dead of night, there are small cold fires in the logs. Fungi can break down oil spills. Some species of fungi, given access to petroleum-contaminated soil, will colonize it and begin secreting enzymes that degrade the hydrocarbons into simpler compounds. The soil slowly becomes clean again. Mycoremediation, as it is called, is one of the most promising natural tools we have for healing damaged land. The fungi were doing this, breaking down complex hydrocarbons long before humans made them. They practiced on fallen leaves. The truffle, the expensive, fragrant fungus prized in cooking, grows entirely underground, fruiting close to the roots of specific trees it lives with. It produces its extraordinary aroma specifically to attract animals: pigs, dogs, squirrels, deer. When an animal digs up and eats the truffle, it carries the spores elsewhere and deposits them with its droppings. The truffle has designed an entire system underground to attract creatures from above, use them as dispersal agents, and plant its next generation. It does all of this without eyes, without movement, without any structure we would associate with planning. And yet, the plan works. Lichens are not one organism. They are two, or sometimes three, living so closely together that they appear as one. A lichen is typically a fungus and an alga, and sometimes a bacterium, in a relationship so intimate that neither could survive without the other. The fungus provides structure and water retention. The alga provides photosynthesis. Together, they can grow on bare rock, in deserts, in Arctic wastes, in conditions that neither could survive alone. Life finds a way by finding each other. Lichens grow incredibly slowly, sometimes just a millimeter per year, which makes them remarkably useful to geologists. If you know the growth rate of a particular lichen species in a particular climate, you can estimate the age of the rock surface it is growing on by measuring the diameter of the lichen patch. The lichen has been keeping time, slowly, steadily, patiently, since before you were born, before your parents were born, before the oldest thing you have ever touched was made. You are drifting now, like mycelium through soil, gently, purposefully, in the dark, following some quiet thread toward nourishment and rest. The fungal world is all around you, unseen and ancient. Let it be there. Let it do its work. And let yourself go a little deeper into this soft, nourishing dark. The night is very deep now. You have been traveling a long way, through forests and meadows, along rivers and up into the mountains, into the sky and back down again, into the dark. Your body knows how to rest. It has always known. It was built for this, the same way a tree was built to know when to drop its leaves, the same way a salmon was built to know the smell of home. Let's talk about the sea for a while. Let its sound be inside you, that slow, rhythmic breathing that has never stopped. The ocean covers 71% of the Earth's surface and contains 97% of all the water on the planet. It has an average depth of about 3.5 kilometers, but at its deepest point, the Mariana Trench in the Pacific, it reaches nearly 11 kilometers down. The weight of the water there is more than 1,000 times the pressure at the surface. And yet, life lives there. Bacteria, small shrimp-like creatures, sea cucumbers. Life has answered every extreme the ocean offered with a quiet, persistent yes. Humpback whales sing. Their songs can last for 20 minutes and can be heard hundreds of kilometers away. The songs change over time. New phrases appear and spread through the population, the way a song passes between people. Within a season, all the humpbacks in a given ocean will be singing the same new phrase, which was invented by a single animal and spread from whale to whale. The ocean carries music, and whales are its composers. Dolphins live in complex social groups and cooperate in hunting, sometimes herding fish into tight balls that each dolphin takes turns rushing through to feed. Off the coast of Brazil, some bottlenose dolphins have learned to drive mullet into the nets of waiting fishermen, then signal with a tail slap when to throw the net. The fishermen and the dolphins have been doing this for generations, a cross-species partnership passed down through human families and dolphin pods alike. The playlist carries many more evenings like this one, each story a gentle door into a different part of the natural world. Do come back anytime. Whale sharks, the largest fish in the sea, are filter feeders, opening their enormous mouths and moving slowly through the water as small fish and plankton wash in. Despite their size, they are gentle. They sometimes allow divers to swim alongside them. Their skin, if you could touch it, would feel like very coarse sandpaper, thousands of tiny dermal denticles, each one a miniature tooth. Their skin is made of teeth. The whole body is armored in a quiet, ancient way. Sea otters use tools. They carry a flat stone under their armpit, and when they find a mussel or clam, they float on their back, balance the stone on their belly, and smash the shellfish against it to break it open. The stone they have is usually a good one, the right shape, the right weight, and they keep it for days or weeks, carrying it with them from one dive to the next. The stone is their instrument, carefully selected and maintained. Octopuses are perhaps the most alien intelligence on Earth. Their nervous system is distributed throughout their body. 2/3 of their neurons are not in their central brain, but in their 8 arms, which can act semi-independently, solving problems their own way, while the central brain attends to something else. An octopus can recognize individual humans, open jars, play with objects, find its way through mazes, and learn by watching other octopuses. They dream, or at least they show complex patterns of movement and color change during rest that look very much like dreaming. The giant squid lives in the deep ocean and has eyes the size of dinner plates, the largest eyes of any living animal, perhaps 30 centimeters in diameter. It needs them to see in the faint blue light of the deep sea. With those huge eyes, it can detect the faint bioluminescent glow of sperm whales approaching from far away, giving it time to escape the only predator large enough to threaten it. The eye is intelligence made visible, a complex instrument evolved to answer a specific, difficult question about the world. Cuttlefish change their color and texture in milliseconds, not just to camouflage themselves, but to communicate. Two cuttlefish meeting on a reef will display rippling patterns of light and dark on their skin, exchanging information about identity, mood, and intention in a continuously shifting visual conversation. They can display different patterns on the left and right sides of their body simultaneously, showing camouflage to one side and a courtship display to the other. Two messages at once, without confusion. Coral polyps can smell. When a larva settles on a reef, it chooses its spot based on chemical cues from the reef itself. Specifically, the smell of crustose coralline algae, a particular kind of algae that grows on healthy reef surfaces. The larva is responding to the chemical signature of a healthy home. It is choosing carefully before it commits to a place it will spend its entire life. The coral smells for safety. It chooses quality. It settles into the right place and begins to build. The seahorse is among the most unusual animals in the sea. The male carries the young. The female deposits her eggs into a brood pouch on the male's body, and he gestates them, nourishes them, and gives birth to hundreds of live young through muscular contractions. A pregnant male seahorse, gripping seagrass with his curled tail, swaying gently in the current, small, patient, extraordinary, is tending his family in the sea's own rhythm. The tidal pools at the edge of the ocean are among the most densely inhabited places on Earth. In a space you could step across, there may be sea stars, anemones, limpets, hermit crabs, blennies, shore crabs, mussels, barnacles, periwinkles, and a dozen species of algae, all arranged in distinct zones based on how often they are submerged. Each organism has found its exact niche, the exact amount of wetting and drying it can best tolerate, the exact position in the pool that suits it best. The pool is a map of tolerance and preference, drawn in living creatures. The sea breathes. It has always breathed. Long before you were born, it was doing this, pulling carbon from the air, cycling nutrients through its depths, cooling the tropics, feeding the poles. It was breathing when the first fish swam in it, when the first tetrapod hauled itself onto land, when the first bird flew above its surface. And it is breathing right now, softly, steadily, somewhere far and near at once. Let its rhythm enter your own. Breathe with the sea for a moment. In, out, in, out. You are still. The sea breathes. The forest breathes. The meadow breathes. And you, here in the warm and gathering dark, are part of all of it. One more breathing thing in a world full of breathing things, each one knowing, in its own deep way, exactly what to do. There are creatures on this earth that have barely changed in hundreds of millions of years, not because they failed to evolve, but because they arrived at such a good solution so long ago that nothing has needed changing since. Let's visit some of them. The horseshoe crab has existed for roughly 450 million years, longer than the dinosaurs, longer than the first forests, longer than the first insects. It looks like a helmet with a tail moving slowly across the ocean floor, its book gills breathing through the water. Its blood is blue, copper-based rather than iron-based, and has an extraordinary property. It clots almost instantly in the presence of bacterial toxins. Every injectable medicine in the world, every vaccine, is tested for safety using a compound derived from horseshoe crab blood. This ancient creature, unchanged since before the first flowers bloomed, is a guardian of human health. The nautilus has existed for roughly 500 million years. Its spiral shell, the famous logarithmic spiral, growing outward from a central point, is one of the most beautiful shapes in the natural world, and one of the most mathematically elegant. The nautilus itself moves by jet propulsion, pulling water into its body cavity and forcing it out, gliding through the deep ocean with a slow, easy rhythm. Inside the shell are a series of chambers, each one sealed off as the nautilus grows into a larger one, the older chambers filled with gas for buoyancy control. The whole structure is a masterwork of engineering, designed over 500 million years of quiet revision. Sharks have existed for roughly 450 million years and have changed remarkably little. They are perfectly tuned to what they do. Their skin, covered in those tiny denticles, reduces drag in the water so effectively that the pattern has been copied in competitive swimming suits. They have a sensory organ called the lateral line that detects pressure changes and vibrations in the water, essentially feeling the movements of nearby creatures. And they have the ampullae of Lorenzini, tiny pores around the snout that detect the electrical fields generated by the heartbeats of prey animals. A shark can find a motionless fish buried in sand simply by feeling its heartbeat. If you've been resting with us for a while, a like means a great deal. It's the channel's quiet way of knowing you were here. Dragonflies are 400 million years old in their basic form. Their compound eyes, made up of 30,000 individual lenses, give them nearly 360 degrees of vision. They are among the most successful aerial hunters in the animal kingdom. They catch their prey in midair with a success rate of over 90%. They calculate the future position of their prey and fly to meet it there rather than chasing where it was. They think ahead, they predict. And they have been doing this since before the dinosaurs. Ferns have been growing on Earth for 360 million years. They were here before flowers, before birds, before most of the animals we recognize today. Their method of reproduction, through spores released from the underside of their fronds, is ancient and reliable. A fern uncurling in spring, the fiddlehead tightly coiled, then slowly opening, is doing what ferns have done since the Devonian period. It is one of the oldest gestures in the natural world, the unfurling of green life toward light. The coelacanth was thought to have gone extinct 65 million years ago, until a living specimen was caught off the coast of South Africa in 1938. It lives in deep ocean caves and has changed so little that fossils from hundreds of millions of years ago are almost indistinguishable from the living fish. Its fins move in a walking-like pattern, in the same sequence as four-limbed animals walking on land suggesting that it represents, alive and swimming today, something close to the ancestor of all land vertebrates. It is a living bridge between the sea and the land. Ginkgo trees have existed for 270 million years, a single species unchanged since the time of the dinosaurs, spreading its distinctive fan-shaped leaves each spring and turning golden each autumn, as it always has. They survive in the hardest conditions: polluted cities, poor soils, extreme cold. Several ginkgos survived the atomic bombing of Hiroshima, less than 2 kilometers from the blast site. They are still there, growing. They have outlasted everything: the coelacanth, the horseshoe crab, the nautilus, the shark, the fern. They are not primitive. Primitive implies incomplete, unfinished. These creatures are complete. They are the final form of long experiments, carried out over geological time, in which every unnecessary feature was removed and every essential one refined to perfection. They are like poems that have been revised for 400 million years and need no further editing. Sponges, simple, porous, filter-feeding animals that live attached to the seafloor, are thought to be among the first multicellular animals ever to have evolved, some 800 million years ago. They have no nervous system, no muscle, no movement. They simply sit and let the ocean pass through them, filtering out bacteria and organic particles. And yet, they are alive. They respond to stimuli. They can regenerate entire bodies from tiny fragments. A sponge is life at its most essential, without any of the additions that came later. It is the first note of a very long song. Stromatolites are layered rock formations built by cyanobacteria, microorganisms that may be the most important creatures in the history of this planet. 3.5 billion years ago, cyanobacteria began producing oxygen through photosynthesis, slowly changing the Earth's atmosphere from one with almost no oxygen to one rich in it. The Great Oxidation Event, the moment the world's air became breathable, was caused by these invisible, ancient beings doing nothing more than living and breathing. Every breath you take was made possible by them. Every animal on Earth owes its existence to their quiet, ancient work. You are breathing air that was made over billions of years by the smallest and most patient beings on Earth. There is nothing more ordinary than this breath. There is nothing more extraordinary, in and out, as it always has been, as it always will be. You are held inside a chain of breathing that goes back to the beginning of life on this planet, and it goes on through you and will go on long after you in the endless, gentle intelligence of the living world. It is very late, or perhaps it is very early. In the deep of the night, the two are the same, a single long breathing pause between one day and another. The world outside is soft and still. Whatever sounds you can hear, wind in leaves, the distant movement of water, the settling of the house around you, are the sounds of the world doing its quiet, continuous work. It will not stop. You can rest inside it completely. Let's think about seeds for a while. Small, patient, extraordinary things. A seed is a beginning held in suspension. Inside the hard outer shell, the testa, is an embryo, a tiny, complete plant, waiting. With it is packed a supply of food, carbohydrates and fats and proteins, carefully stored, enough to get the seedling started before it can make its own food through photosynthesis. Everything the plant needs for its first hours of life is wrapped up, sealed, and made to wait. Seeds can wait a very long time. The oldest viable seed ever germinated was from a Judean date palm, grown from a 2,000-year-old seed found in the archaeological site of Masada in Israel. It germinated and grew into a healthy tree, a tree whose ancestors had been extinct for centuries, revived from a seed that had waited patiently through the entire span of recorded history. The seed held its instruction set intact across 2,000 years and then, in the right conditions, began. Lotus seeds have germinated after more than 1,000 years of dormancy. Arctic lupine seeds have germinated after being frozen in permafrost for perhaps 10,000 years. The instructions for life, encoded in DNA wrapped in a seed coat stored in the right conditions, can persist across spans of time that dwarf any human civilization. Life is extraordinarily patient about beginning. There are many more stories in the playlist, each one a different world to rest in. Come back anytime the night feels long. Some seeds require very specific conditions to germinate. The king protea of South Africa will not germinate without smoke, specifically a compound called carrageenanide, which is produced by burning plant material. Its seeds wait in the soil for years, held dormant until a wildfire passes. The smoke triggers germination. The seed does not mistake a campfire for the right signal. It waits for the particular chemistry of a large landscape-scale fire. Then the field blooms with proteas in the ash. A coconut can float for a year in the ocean without losing its viability. The thick husk keeps the seed inside dry and cushioned, and the buoyant structure keeps it afloat. Coconuts have colonized remote islands across the Pacific and Indian Oceans this way, drifting on ocean currents, sometimes for thousands of kilometers, until a beach accepts them. The palm tree that grows from it will produce thousands more coconuts, which will drift to thousands more shores. An empire built on patience and ocean currents. The seeds of many plants have hooks, barbs, or sticky surfaces that catch on the fur of passing animals, or, in the modern world, on the socks and shoelaces of passing humans. The burdock, famous for the invention of Velcro, its seed pods caught in an engineer's dog's fur, and he looked closely at them and saw the simple mechanism that became one of the most used fasteners in the world, sends its seeds wherever animals go. The plant has been hitching rides for millions of years. Maple seeds spin as they fall. The wing-like structure, the samara, is shaped so precisely that as it falls, it generates a tiny vortex above the wing, creating low pressure that slows the descent and gives the seed time to drift on the wind. Engineers studying maple seeds discovered that the same aerodynamic principle is used in some helicopter designs. The maple arrived at it first through millions of years of trial and revision. The seeds of orchids are among the smallest in the plant kingdom, some so fine they look like dust, each one containing barely more than a few hundred cells. A single orchid pod can contain 3 million seeds. Because the seeds are so small, they carry almost no food reserve. They must land in a place where the right mycorrhizal fungus is already present to nourish them through germination. They gamble on abundance, sending millions of tiny messengers into the world and trusting that some will land in the right place at the right time. Squirrels bury acorns for winter and sometimes forget where they buried them. The forgotten caches germinate in spring and become oak trees. The squirrel, by its forgetfulness, becomes a planter. Every oak forest in Europe and North America is, to some degree, the result of squirrel forgetfulness. An accidental arborist creating forests it will never see, in places it happened to be, in moments it didn't quite remember. A fig and a specific fig wasp are so intimately linked that neither can reproduce without the other. The wasp enters the fig to lay eggs, and in doing so, pollinates the flower inside. When the new wasps emerge, they carry pollen with them to the next fig. The fig and the wasp have evolved together so completely that each fig species has its own dedicated wasp species. There are over 900 species of figs on Earth. There are over 900 species of fig wasps. Each pair evolved together over millions of years into a relationship as specific and essential as a lock and a key. A single teaspoon of healthy soil contains more living organisms than there are people on Earth. Bacteria, fungi, nematodes, protists, insects, mites. The soil is not the background for life. The soil is life. Every seed that falls into healthy soil lands among an entire civilization, which will feed it, protect it, communicate with it, and integrate it into the community of the living. The seed is not alone. It never was. Think of yourself as a seed right now, small, complete, held in the dark, warm, and still. Everything you need is already inside you. You don't need to do anything. You simply need to rest in the right conditions, warmth, quiet, stillness, and trust that what needs to happen next will happen in its own time, in its own good way. You are held. You are complete. You can sleep. There is a sound that comes just before dawn. Not a bird, not a wind, not anything you could quite name. A change in the quality of the silence. A deepening just before the world prepares to turn toward light again. We are there now, in that last, most restful hour, when the body does its deepest healing, when dreams come softest, when the whole natural world seems to hold its breath for just a moment before the day begins. Let's think about how nature heals itself. It does this with extraordinary patience and intelligence. When a forest is cleared or burned, it does not stay empty. A specific sequence of plants, called pioneer species, arrives first. Fast-growing, light-loving, often considered weeds, fireweed, bracken, birch. These pioneers stabilize the soil, fix nitrogen, create shade, and change the microclimate. Within years, shrubs arrive. Within decades, slower-growing trees. Within a century, in the right conditions, a mature forest can reestablish itself. Different in its exact composition, but fulfilling the same ecological roles as the one before it. The forest remembers what it was supposed to be and rebuilds itself, one patient step at a time. Coral reefs can recover from damage, bleaching events, storms, crown of thorns, starfish, if given enough time and the right conditions. Corals that survive a bleaching event develop a kind of heat tolerance that their descendants may inherit. The reef does not simply recover to where it was. It rebuilds slightly differently, adjusted to the new conditions, changed by what it survived. The reef is learning in its slow, geological way. Beaver dams, often seen as nuisances, are extraordinary landscape healers. A beaver pond floods the surrounding land, killing some trees but creating wetland habitat that supports hundreds of other species. The still water collects sediment, purifies water, recharges groundwater, and dampens floods, downstream. After a beaver dam has been in place for decades, the pond gradually fills with sediment and the beaver moves on, leaving behind a rich, flat meadow, a beaver meadow, of the most fertile soil in the forest. The beaver has built a meadow, without intending to, without any planning, simply by living according to its own nature. If you've been here with us tonight, a comment would be a beautiful thing to leave behind, and the playlist waits for you on another quiet evening. Mycorrhizal fungi connect not just trees of the same species, but trees of different species, creating a network of mutual support across the entire forest. When a tree is cut or falls, the network helps the remaining stumps stay alive for years, sometimes decades, by channeling sugars from nearby trees through the roots. Old stumps, long after their last branch has fallen, continue to live quietly underground, fed by their community. No one is left behind in a healthy forest. Wolves, reintroduced to Yellowstone in 1995 after a 70-year absence, changed the rivers. Their predation on elk, which had overgrazed the riverbanks, allowed vegetation to return to the banks. The roots stabilized the soil. The banks stopped eroding. The rivers ran straighter and cleaner. Fish returned. Beavers returned. The whole ecosystem reorganized itself around the return of one predator. This is called a trophic cascade, a change at the top of the food chain, rippling down through every layer of the ecosystem, all the way to the shape of the rivers. Everything is connected. Change one thing and everything adjusts. Earthworms are quiet restorers. They eat soil, literally eating the earth, passing it through their bodies, digesting organic matter, and depositing it as castings that are extraordinarily rich in nutrients and beneficial bacteria. A single earthworm can process several tons of soil per year. In a healthy meadow, the earthworms beneath it turn the entire top layer of soil every few years, aerating it, mixing it, making it fertile. Charles Darwin spent 40 years studying earthworms and concluded that they were among the most important creatures in the history of the earth. Soil itself is alive. A healthy handful of soil contains bacterial species that are not found anywhere else in the world, specific to that field, that hillside, that garden. The soil is not inert. It is a community, a civilization, a living system that has been developing its particular character for thousands of years. Healthy soil smells of life. Petrichor, that distinctive smell of rain on dry earth, is partly caused by a compound called geosmin, released by soil bacteria when moisture arrives. The smell of rain on earth is the smell of a living community, activated and releasing its chemical signature into the air. Phytoplankton, microscopic algae that live near the surface of the ocean, produce roughly half of the oxygen in Earth's atmosphere. They are single-celled, invisible to the naked eye, and they drift in their billions at the mercy of ocean currents. And yet, together, they oxygenate the world. They do this simply by living, by converting sunlight and carbon dioxide into their own bodies, releasing oxygen as a byproduct. Every other breath you take was produced by the ocean. You are breathing the sea. When a whale dies and sinks to the seafloor, a whale fall. It becomes an entire ecosystem in itself. Bacteria, hagfish, and crabs consume the soft tissue over months. Then, organisms that can digest fat move in. Finally, Bacteria specializing in decomposing bone create a hydrogen sulfide-rich environment around the skeleton, supporting communities of tube worms, clams, and mussels that normally live near hydrothermal vents. Creatures of deep chemical darkness arriving at a whale skeleton to feed on its slow release. A whale fall can support new life for decades. The whale continues to give long after it stops swimming. A forest after a wildfire looks, at first, like a devastation. But beneath the charred surface, the seeds are preparing. The bulbs are intact. The mycorrhizal network, protected deeper in the soil, is still connected. Within weeks, fireweed blooms in impossible quantities, bright purple against the black. Within years, the aspen sends up new shoots from its undamaged roots. The forest does not experience its own burning as tragedy. It has survived many fires. It has always come back. It comes back different. It comes back. Let your body remember its own capacity to heal. The way a cut closes, the way sleep restores, the way morning always comes after even the darkest night. You are, like the forest, made of something that persists, that finds its way back, that rests now in the dark, gathering itself for what comes next. Rest in that knowing. Rest completely. The morning will take care of itself. You are very nearly asleep. Your breathing has slowed to the pace of the forest's breathing, that deep, wordless exchange between root and sky that has been going on since the first tree grew on this planet. Your body knows what to do with this stillness. It is doing it now, quietly, without any instruction from you. All the systems of your body are working together in the dark. The same way the forest systems work together, the same way the ocean systems work together, with a deep, unhurried intelligence that requires nothing from your conscious mind. Everything is working. Everything is as it should be. The human body contains approximately 37 trillion cells. Each one is carrying out hundreds of chemical reactions every second, converting nutrients to energy, repairing DNA, communicating with neighboring cells, responding to signals from across the body. The liver is processing, the immune system is patrolling, the heart is beating its quiet, faithful rhythm. Your brain is sorting and filing the day's experiences, moving important memories into long-term storage, releasing the rest. You are, right now, as complex and quietly intelligent as a forest. Your gut contains more neurons than your spinal cord, about 100 million of them, along with a vast community of microorganisms, bacteria, archaea, fungi, and viruses, perhaps 10,000 species in total. They digest your food, produce vitamins, regulate your immune system, and communicate with your brain through the vagus nerve. They have co-evolved with humans over hundreds of thousands of years. They are not foreign inhabitants. They are partners, as essential to you as mycorrhizal fungi are to the forest. You are, like the tree, a community. Sleep itself is deeply intelligent. During the night, your brain's glymphatic system, a network of channels that open during sleep, flushes out metabolic waste products that accumulate during waking hours. Some of these waste products, if allowed to build up, are associated with neurodegenerative diseases. Sleep cleans the brain. It is not passive rest. It is active, purposeful, essential maintenance. The same kind of work the earthworm does for the soil, the same kind of work the whale fall does for the seafloor. The body restores itself in the dark. We are nearly at the end of tonight's story. If it has been a good companion, a like before you sleep would mean a great deal. to this quiet little channel. The cells of your body replace themselves continuously. Most of your skin cells are replaced every 2 to 3 weeks. Your red blood cells every 4 months. Your taste buds every 10 days. The cells of your liver every 5 months or so. Some cells, neurons in certain brain regions, stay with you your whole life. Others are constantly being made and unmade. You are, like the forest, never quite the same from one season to the next, and yet, continuously, recognizably, yourself. Your heart beats about 100,000 times a day, about 40 million times a year, for your entire life, adjusting its pace hundreds of times per hour in response to your activity, your breathing, your emotions. It does this without any instruction from your conscious mind. It has been doing it since before you were born. The heart began beating when you were less than 5 weeks old, smaller than a grape, barely recognizable as human, and has not stopped since. It is the most faithful thing in your life. The breath is the only autonomic function you can also consciously control. You don't need to think about breathing. Your brainstem manages it automatically, adjusting the rate and depth based on the carbon dioxide levels in your blood. But you can also choose to breathe slowly, to breathe deeply, to use the breath as a tool for calming the nervous system. In this, breathing is a bridge between the conscious and the unconscious, between intention and the body's own deep intelligence. When you breathe slowly, you are speaking to your nervous system in its own language. The eyes at rest make tiny unconscious movements called microsaccades, small, rapid jitters that keep the visual field refreshed and prevent the image from fading. Even in stillness, even in sleep, the eye is doing something small and continuous. The body does not fully stop. It hums quietly, maintaining itself through every moment of rest. Your bones are not inert. They are living tissue, constantly being remodeled. Old bone is broken down, and new bone is built in a continuous cycle managed by 2 types of cells, osteoclasts and osteoblasts, working in balance. When you sleep, this remodeling accelerates. Sleep is when your body does its most essential structural maintenance. Your bones are being rebuilt right now, in the dark, while you rest. You will wake up quietly, slightly different than when you lay down, slightly repaired, slightly renewed. The human eye contains approximately 120 million rod cells for detecting light and shadow, and about 6 million cone cells for detecting color. In the right conditions, a human eye can detect a single photon of light. The eye is one of the most sensitive instruments in the natural world, evolved over hundreds of millions of years, from simple, light-sensitive patches in the first animals to the complex, extraordinary structure that lets you read these words. Every time you see something beautiful, you're using an instrument that took 500 million years to build. Even in sleep, the brain is not idle. It cycles through stages of rest and activity: light sleep, deep sleep, REM sleep, each one essential. In REM sleep, the brain is nearly as active as when awake. Dreams occur, emotions are processed, problems sometimes are solved. Researchers have found that people perform better on creative tasks after sleeping. The unconscious mind continues to work on problems, finding connections and solutions that the tired, focused daytime mind could not. Sleep is not a pause in your thinking. It is a different kind of thinking. You are intelligent, not just in the ways you know, in thought and language and memory, but in the millions of ways your body knows, the ways your immune system recognizes a pathogen it has never seen before, the way your hand knows to pull back from heat before your conscious mind has registered the danger, the way your lungs know to expand and contract in the exactly right rhythm for this moment. You are as full of quiet, wordless intelligence as the forest, as the ocean, as the stars. And right now, all of that intelligence is doing one thing: resting. Resting deeply, resting completely. You can trust it. It knows exactly what to do. And now we come to the end of our time together tonight. Though the world will keep going while you sleep in all its quiet, extraordinary ways, the forest will breathe, the tide will turn, the mycorrhizal threads beneath the trees will pass their slow chemical messages back and forth. The stars will continue their patient, ancient burning. The seeds in the soil will wait. The salmon in the river will hold themselves in the current, barely moving, resting in the cold water. All of it will go on. You don't need to watch over it. It knows what to do. The natural world has been intelligent for longer than there were creatures capable of recognizing intelligence. Long before any eye opened, long before any brain formed, there were organisms doing complicated, purposeful things, finding light, avoiding toxins, seeking nutrients, communicating with each other through chemicals and electricity and sound. The cyanobacteria oxygenating the ancient ocean had no awareness of what they were doing. They simply lived. And in living, they changed everything. Intelligence in nature is not something special that belongs only to the few complicated creatures, the dolphins and the crows and the octopuses. It is woven into the fabric of everything. It is in the way a root finds water, in the way a seed waits, in the way mycelium solves the problem of the forest floor, in the way a coral chooses where to settle, in the way the weather finds its pattern through a landscape. Intelligence in nature is not a possession. It is a way of being, and you are part of nature, not apart from it, observing it, in it. When you breathe, you are participating in the same cycle of oxygen and carbon dioxide that the forests and the oceans maintain. When you drink water, you are drinking something that has been inside clouds, glaciers, ancient seas, and the bodies of creatures that lived before your great-great-grandparents were born. When you rest, you are doing what every animal, every cell, every living thing does, giving the body time to repair, restore, and prepare for what comes next. There is a moment in every deep forest in the late afternoon when the light is long and horizontal and the birds have stopped for a little while, when everything seems to listen, not for anything in particular, just to itself, a quality of attention without object, the trees paying attention to the air paying attention to the trees, the whole forest quiet and self-aware in some way that has no name. That is where you are now, in that stillness, in that listening quality, not waiting for anything, not holding on to anything. Simply here, in the warm dark, in the company of a world that is ancient and patient and full of a quiet intelligence that has never stopped, not for a single moment since life first began on this small blue planet. The ants are resting in their chambers. The bees are clustered in their hive, vibrating gently to keep the colony warm. The trees have drawn their water up from the roots, and are quiet now, storing the day's sugars. The whale is drifting through deep water, half its brain asleep, half its brain watching the dark. The migratory birds are resting on their perches, one foot tucked up, dreaming, perhaps, of the long journey still ahead. The moss is simply being moss, as it always is, cold and green and without hurry. And you are here, warm, safe, complete. Close your eyes, if they are not already closed. Let your hands rest wherever they have fallen. Let the weight of your body be entirely held by whatever is beneath you. You don't need to hold yourself up. The earth is doing that. It has always done that. It will go on doing it while you sleep. There is nothing to solve right now, nothing to remember, nothing to prepare for. All of that belongs to tomorrow, and tomorrow has its own intelligence. Tonight belongs to rest. You are a breathing, dreaming, living part of the most extraordinary world that has ever existed. A world that spent 4 billion years figuring out how to make something as complicated and beautiful and temporary as you. And right now, that world asks only one thing of you: to sleep. So sleep. Sleep the way the seed sleeps, held and waiting, full of everything it needs. Sleep the way the stone sleeps in the river, cool and smooth and perfectly still, held in the moving water, going nowhere, needing nothing. Sleep the way the forest sleeps, breathing quietly in and out, roots deep, canopy still, the whole vast living thing at rest in the dark. Good night. You are safe. You are held. The natural world will watch over itself tonight, as it always has, and you can let it, completely, trustingly, without another thought.